I'm hoping that those who will be joining us online will join us as early as possible. So the name of the course is Database Systems. And basically, this course is supposed to guide you on how to design databases. That's one. And also how to develop database, right? So you will be introduced to the several different types of databases that we have and certain concepts that are related to database systems, like entity relationship models, normalization, querying languages, relational algebra, calculus. This is just concepts. We are not going deep. We are just showing you. We are going to talk about the concepts, how they are used to be applied in database systems. So the reason I'm highlighting SQL will be the main database language we'll be learning, and it's a relational database systems. So I'll be telling you why that is being chosen. So the objectives of the course is that at the end of the course, we should be able to have a comprehensive understanding of the principles of database systems, data models, and database management systems. You should be able to design and implement effective database schemas using what? Entity relationship modeling. So you will learn what we mean by entity relationship modeling and how to draw an entity relationship model. And you should be able to compose and execute queries using SQL, structured query language. Yes, in order to retrieve and manipulate data. Be able to normalize databases to ensure data consistency and minimize redundancy. So all these are terms that at the end of this course, you should know what it means. Be able to understand database architectures, transaction management, concurrency control. And then finally, you should be able to apply database systems knowledge to real-world applications and problem solving. So as part of assignments you'll be doing, you'll be asked to create your own database for a purpose, either for a need in your institution or whatever, applying the knowledge that we are going to be teaching you. All right, there are a couple of books that you can rely on throughout this course. I've listed them here. They are all reading materials. I also ensure that my slides that I'll be using are going to be resourceful as much as possible. So, without much ado, we are going to start with the introductory lecture, which is lecture 1. Introduction to databases. Yeah, so I'm still a candidate. I've not yet attained my PhD. I'm still working on it. Inshallah. Inshallah. Amen. Okay. Yes. For my professional. So these are the objectives of today's lecture. So let's look at the internet and mobile device world. Something we call the client server architecture. This diagram here basically depicts client server architecture. Who are the clients? The clients are these guys here. The users. We are the clients. Hmm? We are the clients. Okay. And the devices that we use are also the clients. We ourselves and the devices we use to access the internet are the clients. Now, through the internet, we access information from servers, the websites we access, the MIS systems, the UCM, and the what have you, over the internet. We access it from a server. So the server is right there. Now, these servers have what we call database, where information is being stored. You get it? So through the internet, the clients access what? The server. The server has picks information from the database and serve it to us. So if we are saving an information, it will pass through the internet to the server into the database. If we are extracting an information like we want to view our results, it will also pass through the database to the server and then to us. Similarly, in that order. In this case, we have a laptop or a computer, and here we have a smartphone. And we know you're either accessing the internet through your PC or through your smartphone. You get the point. With a phone, you may be accessing an application data server. A server is also a server, but probably a server that is serving a mobile app or giving information to a mobile app. But all in all, database stands as the final architecture where information is stored and retrieved. You get it? Hmm. Managed, retrieved. Managed includes storing, retrieving, modifying, deleting. Yes, every data, every information is inside the database. Yeah, so databases are actually very important. In fact, without databases, our web, the internet will be empty. Empty. Imagine going to Facebook and not being able to see content. Imagine you're on Facebook, nothing is there for you. Mhm. Yes, your pictures, your status post, everything goes into a database. Who manages it? Who manages it? The experts, of course. Huh? Yeah, of course. Of course, they have it. Facebook, they have their database engineers who are managing it for you. If the server is down, the server contains the databases. If it's down, you cannot access it. Even the Facebook will not work. There are instances like that whereby there are issues with their server and then the whole system stops to work. Even WhatsApp once went down like that. You send message, it won't go. Somebody send you message, it doesn't come. But your internet is working. Why? Because the server is down and it is impacting the database too. Correct. You see the first diagram I showed you. So if server has problem, then you cannot get information from the database. So you realize that only information that is on your phone that is there. But any other information to pull from internet and come and go. Oh, yeah, yeah. Information. Mm. So everywhere, every day, whatever we are using, Facebook, Twitter, shopping, everything involves what? Database. Hmm? Yeah. So just a quick glance on the internet, personal computers, local area networks, ARPANET, World Wide Web. This thing we have talked about it in web development. The mid 1970s, phones started springing out. Then we have the age of the smartphones, starting from Apple. They did the first iPhone. Apple they led the smartphone generation, like proper smartphone. Mm. Then Android also came from Google. Mm. The first, yeah, Apple iPhone. Yeah. Mm? Uh, uh, yeah, if you see the old iPhone, it's some big thing be like that. Yes. Then tablets came. That's the iPad, Apple, by Apple. Now, then this brought the age of mobile apps. WhatsApp and co. Right? Hmm. So let's look at the characteristics of databases. The purpose of a database is to help people track things of interest to them. Data is stored in tables. In a database, you store data in tables. And these tables have rows and columns, like a spreadsheet. Database may have multiple tables where each table stores data about a different thing. Each row in a table stores data about an occurrence or instance of the thing of interest. The database stores data and relationships. So what we are saying is that a database consists of tables. Each table represents something of interest that we want to store. Maybe student information, maybe applications, maybe resource, and what have you. Yes, yes. You understand? It's all based on your capacity and your need. Yes. So in the tables, in each table there are rows and columns. Rows and columns. Rows are columns are basically the columns are like the titles, name, country, contact, that order. Then everybody's information will be in a row, row. Just like you have in an Excel sheet. That's what we mean. Each row in a table will store a data about an occurrence or an instance of thing of interest. If it's students, each row stores information about the students in that order. Yeah. And then we say it stores database stores data. And then what? Relationships. It can also store relationships. When we say relationship, we are meaning that connection between one entity and the other. For example, a student and their resource. That's a relationship. Resource table is separate. Student table is separate, but there can be a connection between the two. Okay. This is just a depiction. We have what we call primary key, surrogate key. I'll explain this in our next lecture. But if you are reading it, you can read and understand. So subsequent, these are diagrams from Microsoft Access 2013. Do you know Microsoft Access is a database system? Yes. MS Access, the easiest. The easiest. Oh yeah. Mm. Okay. So what's data? Data basically refers to recorded facts and figures. Information, when we say information, we're looking at what knowledge can be derived from the data. Now we want to make meaning from the data. That is information. So we say databases record data, but they do so in such a way that we can produce information from the data. So we store data inside the database, but then at the end of the day, we can produce information from it. We can query it. For example, the data on students, classes, and their grades could produce information about each student's GPA. So if I pick your student's information and I pick which class they belong and I pick their results and I put it together, I can calculate their GPA, and that is what information now. So you have first class, you have second class, you have third class. You get the point. Yeah. Yeah, these are examples of database applications. Those who use it, number of users, typical database size, and whatever. So a database system, we have the user here, the database application. This can mean the, what do you call it? The UCM that you use, the interface of the UCM. I'm just giving an example, right? The interface can be the database application. Then the DBMS. A DBMS is the a database management system itself, which is connected to the database. This component actually works with the Access MS Access database system. This is the kind of architecture or components within it. But we also have components for a database system that is using SQL. Hmm? For those ones, we have the user, the database application, and then the structured query language. That's an is there as a bridge, help you access the DBMS and subsequently the database. So when we say applications, what are the what do they stand for? They stand to mean the computer programs that we usually work with. So as I said, even your UCM, which is a web app, it's also an application for accessing a database. Then we have the database management system. What does it do? It helps you create, process, and administer a database. And the structured query language, that one is an international recognized standard database language. That one is a language. It's used by the programmers when they are programming database. So just like you were learning HTML, go to the website. Database programmers learn SQL to be able to need somebody to be able to create, create information. You need this language. We'll be learning this language. Hmm? Yeah. So this is the basic functions of application programs. Create and processing of forms, process user queries. Yeah. This is access. Actually, I won't teach you access in this course, but I've just put in it here for your own study. So, just a minute. Skipping everything Microsoft Access. Mhm. Yeah, so these are prominent database systems, management systems we have. We have MS Access 2013, MS Microsoft SQL Server, that's also there. For Oral Corporation, MySQL, and then the IBM DB2. All these are different database systems. And then this is a comparison in terms of their power and ease of use. Now look at something here. Microsoft Access, in terms of power, is the lowest. Hmm? As you are going, the more powerful you get. But Access is lowest. Then we have Oracle, MySQL, Microsoft SQL Server, all the way to IBM. So basically, we are saying that IBM Oracle, DB2 Oracle is the strongest or the powerful database. Yes. In fact, even the Netco systems, you know, these are smart meters and what have you. They use Oracle database. You can imagine all the smart meters and all those information is saved in there, and it never crashes. But if it crashes, that's the problem. Hmm? So, but if they are using access, hmm, like 1 week will not reach, the whole system will crash, and then meters will mix up. We'll get free lights. Yes. So that's what the drawing line is that we have the database different types. But in terms of power, they are they are more than each other. I hope you get the point. And that's what I'm trying to say. Exactly. To be also more expensive. These are enterprise, it's expensive to use. I like that one. Then in terms of difficulty of usage, you see that MS Access is lowest, but I mean it's much easier to use than Oracle. If they open Oracle database right now for you, you'll be confused. Because they are independent from lowest all the way to highest. These are the measuring factors. It says we are measuring them based on power and ease of use. Hmm. These are various operating systems that you can run database on. If you're on a Windows, you can run a MySQL database. Linux, you can run Oracle and MySQL. If you're on Apple, you can run MySQL. I'll skip here. Mhm. Hmm. Yeah. Yeah, I think what you have said so far is enough. Read. You can read the rest. I'll share the slide with you. You read the rest, and then you'll be fine. Now, just a quick tip. Going forward, we are going to be we are going to need this database management system, and I would like everybody to download it. Let me share my screen completely so that those online can have a feel of it. DG Postgre. We have database for Postgre SQL. Postgre SQL. So you go to Postgre SQL on Google search, go to downloads, and then you download for the version of your operating system. If you're using Windows, you click on Windows and you download it. I need all of you to download this before next week, and then we'll have it like this PG admin 4. Yeah, so once you download it, once you just click Windows, um, you go to download the installer, and you would download the latest version based on the Yes. Yes, downloading is about to begin. And then you download. I already have it. Once you download it, you can okay, I'll think that you shouldn't do the installation, or I'll share with you a video to follow and install your video. So that when you come back next week, we will be moving to database design. After database design, we'll move to the actual development, and that is where we will use the Postgre to actually write a statement, take database, take data, we to do all kinds of things. So buckle up, buckle up for next week. Please download Postgre SQL as I've just showed you. So we have members online. If you have a question, you can ask. No question, we will call it a day. This introduction, so I have actually introduced the course. Siliconville and Muftau.
There's no question.
Yeah, Dingbe.
I just joined. I just joined, so I
Yes, sir.